Hey there, Seahawks, it's Miss Adams, and in this video, we're going to learn about testing a claim about a mean. All right, conditions for a significance test about mu. So we need to pass the random condition. The data comes from a random sample from the population of interest and the normal/large samples. So this is not large counts like we had for proportion. So for the normal condition, the data comes from an approximately normal distributed population. So if I know that the population distribution is normal, then that condition is met. Or if the sample size is 30 or more, then the central limit theorem is applied. When the sample size is small and the shape of the population distribution is unknown, a graph of the sample data has to show no strong skew or outliers in order for the condition to be met. So there's 3 ways that we could check that condition when we're working with means. All right, the standardized test statistic measures how far a sample statistic is from what we would expect if the null hypothesis were true in standard deviation units. So it is just like a z-score tells you how many standard deviations you are from the mean. The standardized test statistic tells you how many standard deviations we are from what we would expect if the null hypothesis were true. And when we're working with means, it's going to be a t as our test statistic. So t is equal to x bar minus mu, which is what we set our null hypothesis to, divided by the standard deviation of the sample over the square root of n. A t distribution described by a symmetric single peak bell-shaped density curve. Any t distribution is completely specified by its degrees of freedom. When performing inference about a population mean based on a random sample of size n, when the population standard deviation mu is unknown, then we use degrees of freedom n minus 1. So as the sample size gets larger, the t distribution gets closer and closer to becoming a normal distribution. Okay, they look very, very similar, just a little bit more like spread out, I guess. I don't know. In our calculator, we're going to go to stat, test, and we're using the option of t-test. All right, an example, checking the conditions. A tablet computer manufacturer claims that its batteries will last on average of 10.5 hours when playing video. The quality control department randomly selects 20 tablets from each day's production and tests the batteries by playing a video repeatedly until the battery dies. The quality control department will reject the batteries from the day's production run if the mean battery life is less than 10.5 hours. Here are the data from one day. The quality control department will test the hypothesis, the null hypothesis, mu equals 10.5. The alternative mu is less than 10.5, where mu is the true mean battery life in hours while playing videos on a tablet made during the day. Check the conditions for performing the tests are met. So it needs to be a random sample. Okay, so it says randomly selects 20 tablets from each day's production. So that was stated. And then my normal or large samples, I do not have 30 or more samples. So the sample size is small. So we don't know the population distribution if it's normal. So I'm going to have to make a dot plot or histogram or some type of graph of my sample data. So when I make my dot plot, it looks like something like this. And we can see that there is a strong skew and some apparent outliers. So the dot plot shows strong skew and apparent outliers, so this condition is not met. All right, calculating the standardized test statistic. The most popular seafood in America is shrimp. An Illinois shrimp farmer produces about 70,000 jumbo shrimp per 120-day growing season. The target weight for the current growing season is shrimp that weigh 1.25 ounces on average. A randomly selected sample of 60 shrimp produces a mean weight of 1.29 ounces with a standard deviation of 0.11 ounces. The farmer wants to perform a test at an alpha of 0.05 significance level. So we're testing our alternative is a greater than 1.25, where mu is the mean weight in ounces of the population of shrimp during the current growing season. Assume that the conditions for inference are met. So calculate the standardized test statistic. T is going to be equal to x bar minus mu naught, which is my null hypothesis value, over Sx, which is my sample standard deviation, divided by the square root of n. So x bar is 1.29. They gave you that in the problem, minus the null hypothesis mean value is 1.25. The sample standard deviation is 0.11. Again, they gave us that, over the square root of 60, which was my sample size. That gives me a test statistic of 2.817. Find the p-value, so you can either use table B, so this would be a t-table, which I do not believe you're going to have access to on your EOC. So you're going to want to use technology. The degrees of freedom is n minus 1, so 59. So this is a t distribution with 59 degrees of freedom. We have 0 in the center. We're going to 2.817, which was our test statistic. We're shading above because we're doing a greater than test. In our calculator, we go to stat, test, t-test, and we put our information in. We get a p-value of about 0.0033. Okay. Go Seahawks.